Welcome to Part 5 of Competency 6. In this video, we will graph inequalities. Okay, number 1. Which of the following represents the graph of -3 is less than or equal to x? Meaning that, 1, we need a closed circle to show that we have not just an inequality, but an equal situation. So that should be on the -3. So we go over here and we see that for A, we have a -3 that's open. Well, we're not working with an open circle simply because of the line below the inequality, which means less than and equal to. So this closed circle we see in B and C is what we're looking for. So that means we also need to mark out D. So that's not going to work. Now, all of the X values that are going to satisfy that particular inequality means that the arrow needs to point to the greater. It needs to go up. They're all greater, meaning they go to the right of the dot, the closed dot. So go to the -3. Well, on B, they all go down. I like the dot. The dot's okay. But first, that's on 3, not -3. Well, obviously, that's not going to work. So C, yes, C has to work. Why? Closed dot above the correct value, and everything is increasing, meaning all of these values of X to positive infinity will satisfy. And that's what our statement or our inequality means, okay? All right, so let's look at number 2. Same kind of thing going on, looks like. Which of the following represents a graph of x is equal to 5? Okay, because there is no line below my inequality, that means that I need an open circle, open circle. Okay, so if I see a closed circle, which is on D and C, those guys aren't going to help. They will not satisfy. So now I go to the number 5. I find a positive 5. Well, A and B both have a positive 5, and they have open circles above them. Okay, so I agree with that. However, all the values that satisfy this situation are less than the 5. That means that my arrow should be highlighted and pointing towards the left, which would be option B. Everything less than 5, but not including 5, will satisfy that expression I have, or that inequality I have above. Okay, it's actually an inequality, not an expression. Okay, so A does not satisfy because it is going the wrong direction. Okay, let's look at number 3. Okay, number 3. Which of the following represents a graph of -2 less than x, which is less than or equal to 3? Okay, some key points here is that for the -2, we should have an open circle, but for the 3, we should have a closed circle. Okay, now notice that 3 is greater than -2, so all of the x values are in between our two types of circles. Okay, well, right, A has two types of circles, but one of them does not satisfy. The -2 must be open, so that won't work. So let's get rid of A. Now B, that's not even a circle. Well, that won't work. Well, then when we go down to D, we see that we don't have a circle. Well, that isn't going to work. So let's look at C. Open circle above 2, closed circle above 3, everything in between. See how it is actually a line in between? This satisfies, therefore, option C is correct. Okay, now let's look at number 4. Well, the idea of those lines kind of sets us up for something more complex. Okay, so let's say we had a system. Oh, lo and behold, look here, we have a system. So if we have a system and we have two inequalities, a system of inequalities, well, where should that dot be? Where could we have an answer or coordinate pairs that really satisfy? Well, that's the overlapping. Okay, wherever things overlap. Well, this question says, which of the following systems represents a graph given below? Well, for this graph, where these two colors overlap, see where I've got the little dots? Any order pair in here would be great. Okay, now we have to figure out which system that is. Well, this means that we're going to have to check uh, our values. Well, first, don't look at the green because it's clear to look. The green is sort of clear, it's a little ambiguous, but we could look at this purple pink color here, whatever you want to call it, and we could quickly create an equation. The first thing, see how we have a solid line? We have this nice solid line. We have a b value of 4 and a solid line. And notice how we have an x-intercept of 2. That's all real handy. All right, so obviously we could create an equation. Okay, let's create it and then we'll talk about it. So I see y equals, well, I have a b value of plus 4. All right, that looks good. Okay, wait a second. Do we want to equal? I would say we do not. What do we want? Well, everything, the y values are, look at it, they are really below the line. Okay, they all go below. That shaded purple, pink is below. So all the y's are less than, but the line is solid where I have it highlighted. That means we need a line below it. So they're less than or equal to. All the y values are less than or equal to, right? And I'll unhighlight this so we can see it still. Okay, so now I know I have an x here. Now I have to figure out what the slope is. Well, my slope is 4, 1, 2, 3, 4 over 1, 2. Well, you know that 4 over 2 equals 2. But is it positive or negative? It's actually a negative 4 over 2. So that's negative 2. Okay, now you may say, well, gosh, that didn't do any good because you don't have this over here in your options. Well, sure I do. I just need to rewrite it a little bit. So what do? See that negative 2x? Well, put it over on the other side with the y. So add 2x to both sides, okay, to create a zero pair. And yes, I'm skipping steps, okay? So now what do we actually have? We actually have 2x. Oh, that's a funny looking 2. Not that any of my handwriting is not funny. 2x plus y is less than or greater than 4. Okay, do we see that? Well, obviously, option A, I'm looking at A. None of the above. Even look. I mean, there's a 3. I see a 4. I'm not liking that. So I'm going to mark out A. It just doesn't look like it's going to work. Okay, now B. Okay, 2x plus y. Ooh, there's nothing negative about that 4. So I am not going to select B. I don't like that negative 4. Okay, let's look at C. Okay, I like the first equation, C. It It matches what I have, 2x plus y less than or greater than 4. Okay, so I'm going to put a line under that and say definitely a possibility. Okay, now I'm going to look at D. Ooh, but on D, the same equation, the first one, it works too. So how do we solve the situation? How do we look at the two? It's very simple. We have one major difference between the second equations. They look just almost the same except for one thing. On D, it says that it's greater than or equal to. That implies a solid line. Well, let's take a look. That is not the green. That is not a solid line. There is nothing solid. It's obviously a dash line. Well, that implies that we are using greater than or equal to. Now, you may say, wait a second, but the Y, the green is shaded below. Well, okay, let's go another step and rewrite this guy in that form that we need to analyze it correctly. Okay, so let's say negative 3y greater than 2 minus the x. You notice all I did was subtract x from both sides. Now, here's the thing. When we divide by negative 3, each of these, okay, remember that's an understood 1, and that's a negative 3. Ladies and gentlemen, this guy right here, he has to be turned around. Whenever we multiply or divide, if we multiply or divide any inequality by a negative, doesn't matter if we multiply or divide, then the inequality must be flipped around. Now, if you play with those a little, inequalities, and think about what inequalities mean, it would actually make sense. So what do we actually have here? We have that y is greater than negative 2/3, and a negative divided by negative positive. So that's positive 1/3 x. Well, that is, here, let me get rid of these little dot things here. They're kind of distracting. They proved my point at the time, but now they're just a little distracting. So if you think about it, this does look like negative 2/3 for our b value. And then we do go up 2/3 over 2. Well, that is 1/3. Okay. So that would make sense. And you could graph that out on the computer and see that it actually is valid. But it does prove, regardless, that option C is what we're looking at. Okay. It's what we need. It validates it, it proves it. Okay. All right. Well, now let's go to number 5. 5. Which of the following represents a graph of 3x plus y is less than or equal to 7? Okay, so if we put that in y-intercept form, we could really see what the graph should look like. But we can already eliminate 2 items. So in the last question, in question number 4, it came up the difference between a solid line and a dashed line. A solid line is for the less than or equal to, or the greater than or equal to. A dashed line is only less than or greater than. So for C, everything here is less than. And for D, everything here is greater than. So any of the y values would be greater than whatever that line is. And then here, the y would be, here, I can write this like this. The y would be, it would all be less than that line. And if I wrote it like this, I guess it would be It doesn't matter. Regardless, all your y values are greater than the line. And over here with C, all of the values of y are less than your line. And it's really not even a solid line, it's a dotted line. So it's more like a boundary. Okay. So we're not dealing with a boundary. We are dealing with an equality also, which means we have a solid line. So let's think of it this way. Further explanation. If we were to analyze and try to analyze, say, a dot here or over here, okay? When we analyze that, we cannot include that dot. So if we're looking for potential answers, values we need, it will not be on that line. It cannot be on that line because that line is dashed and it really isn't a line. It is a boundary. Therefore, they are thrown out. Now for A and B, different story. Any value on those solid lines are potential solutions, answers, or desired values. Okay, that being said, now that I've said all that, let's solve for the y-intercept, okay? And I see y is less than or greater than 7 minus 3x. Okay, well, both of the lines have negative slopes. Okay, well, that doesn't matter. I need a situation where all of the values are less than the expression. All my y values are less than or equal to. So B is the only situation where my y's are all, see all the dots? They're all below the line. So it's the only one that satisfies. If you look at A, everything is above the line. So it does not satisfy. Okay. All right. This is the last question in this particular video. Again, thank you guys for watching, liking, sharing, and definitely thank you for subscribing. Happy testing, you guys.